So it weakens their old bonds. And then they're not going to stick because remember, I told you that iron attracts electrons, but it attracts electrons very, very weakly. So these bonds are not very strong. It's not like a non-metal which strongly attracts these electrons. So iron is just very weakly attracting these electrons. The next moment, these atoms are going to bounce back. And when they bounce back, even the weak bonds that the iron was making, they're going to break as well. So the next moment, deadsorption happens. So these weak bonds that were formed, they'll eventually break as well. And the atoms are going to fly away. But when that happens, the strong triple bond and the strong bonds between H and H, they've all been broken. And now there's chances of new bonds getting formed. So the next step is deadsorption, which is what it's the weak bonds between reactant and catalyst surface break. And now new bonds can be formed. Okay, so there's two steps, adsorption and then deadsorption. Okay, is this clear?
सर सो लाइक अगर हमारे पास डिफरेंट ट्रांजिशन मेटल है इंस्टेड ऑफ आयरन तो ये एड्जॉर्प्शन और डीअब्जॉर्प्शन कम होगी.
Nee, it might listen. Uh, maybe it's more than iron. For example, if you use platinum, maybe adsorption and deadsorption happens a lot more in the case of platinum. The reason you choose iron is that iron is cheaper. Okay, it's not that costly. Maybe silver is a better catalyst. I mean, industrially, the choices that you make they involve economics as well. Okay, is this part clear?
यस सही है सर.
So it all depends. So transition metals overall they're good catalysts. The problem would have been if you had chosen a non-metal over here on the right side. Then non-metals they attract electrons so strongly that the non-metal will not let go of the. I mean, the bonds that the non-metal would form they would be very very strong because non-metals are very strongly attracted to electrons. Uh, so which is why a non-metal is not going to work as a good catalyst. It might do the first step, but the bonds formed would be too strong and they would not break. Transition metals they don't like to attract. I mean, they attract electrons very very weakly, so they end up forming very very weak bonds with the catalyst on the catalyst surface. Okay, so remember adsorption and deadsorption. That's it. Heterogeneous catalyst. And this applies to all examples of heterogeneous catalyst. Whether it's a contact process or hydrogenation, you just have to remember hydrogenation and sorry, adsorption and deadsorption. Is this clear?
यस सर.
ठीक है. Zoe, clear? Akshita, is this clear?
Yes, sir.
Okay.
Yes, sir.
So next one, homogeneous catalyst. What's a homogeneous catalyst? That the reactant and the catalyst are going to be in the same phase. So they kind of work differently compared to the example that we did above. So catalyst and your reactants are in the same phase. So for example, if I have like in acid rain formation, you have NO2 as a catalyst. So NO2 acts as a catalyst. NO2 oxidizes SO2 and turns it into SO3 and gets reduced. But then in the second step, this NO, it reacts with oxygen and turns back into NO2. So over here in this reaction, this particular reaction, NO2 is your, it is your, it is your catalyst, but it's a homogeneous catalyst. They're all gases. I said then there's a specific example that you have to remember. Tika, I think we did this example in electrochemistry as well, but I'm going to do this again because it's an example of homogeneous catalyst. So in electrochemistry, you had this reaction, which is, Tika, remember, you have to remember this specific example. So there's a reaction which happens between S2O8 ions and I minus 1. अच्छा now ये से mic देख लो. अच्छा, you have this reaction. It's an equilibrium reaction and it's with it's going to form SO4 2 minus. And the E naught for this is 2.01 volts. And there's this I minus 1 equation, which is I2 plus 2 electrons. And it's an equilibrium with 2I minus 1. The E naught for this reaction is 0.54 volts. So I've got these two reactions happening. And remember electrochemistry, it's a higher potential is the one that gains electrons. So this is my higher potential. This is my lower potential. The higher potential gains. And the lower potential is the one that likes to lose electrons. So we can make an overall equation based on this. Higher gains, lower loses. So I'm going to add up the reactants. The reactant in the first one is S2O8 2 minus. The electrons are already balanced. 2 electrons gained, 2 electrons lost. The reactant in the other equation is 2I minus 1. And the product that is forming, okay, what's your product? That's I say in both cases, the product is 2SO4 2 minus, and the other product that's getting formed is I2. So you've got this reaction happening. The E naught cell for this is very, very positive. It's reduction potential minus oxidation potential. So it's 2.01 minus 0.54, which gives me 1.47 volts. And it's very feasible reaction. But it doesn't happen. It's got a very high activation energy. You absolutely get no reaction in this case. So now the question is, can somebody tell me why, even though this reaction is from an electrochemistry point of view, it's very, very feasible, but you absolutely get no reaction out of it. But why does it have a very high activation energy?
सर वो लाइक चार्जेस रिपेल हैं तो रिएक्टेंट्स रिपेल करेंगे इसको.
हाँ ठीक है. The problem is that both ions are negatively charged, so it would be very hard for them to actually collide with each other. They're just going to avoid each other. ठीक है, so they'll repel each other. So like charges repel, they don't react with each other. ठीक है. So बस we'll continue from here. I'll just tell you how adenines act as a catalyst. Okay, we haven't completed this example, so we'll try and complete that in the next class then. Okay. Quick question, any questions? Is this fine?
Yes, sir.
Can you please scroll down? Yeah.
Okay, this one. Send me your email as well. Okay, I'll add you.
Yes.
Okay, we'll continue next time. Okay, tomorrow then.
Okay, sir. Allah Hafiz.
Okay, take
Thank you,
care.
sir.
Love is.
I sent my email.
Okay, just 1 second. Okay, I'm adding you. Okay,
Okay. Uh,
okay, love is.
bye.